that by induction y minus 1 is the factor of y to the power of n minus 1, where n is a natural number. Okay, so let's start this result. Can I state it in a simpler manner? Y1 is a factor of y to the power of n minus 1, right? That's there. So can I state it like this? That y to the power of n minus 1 is equal to, there will be a polynomial, some polynomial f of y times y minus 1, right? You will get some term over here, right? So it shows that y to the power of n minus 1 is divisible, right? You'll get some quotient. Or else you can understand like this. You are having y minus 1, you have y to the power of n minus 1. If you read it, then this will be the question, and here you will get y minus 1. And if you do the division part, this will be gone, this will be gone, and you're left with 0. Okay, so I'm showing you with the polynomial division as well. So let's begin with the proof. Proof step 1. So in the LHS, put n is equal to 1. What it will give be y to the power of 1 minus 1. So it's y to the power of 1 only. So hence, trivially, this will be like equal to RHS, where your f of y will be 1. So this implies n is equal to 1 holds. If you're not able to understand, please go through this division once again. It's a polynomial division. Next is step 2. Assume n is equal to k is true. So what do you get if n is equal to k is true? Y to the power of k minus 1 is f of y, right? Some polynomial f of y minus 1. So this is your star. Now, step 3. To prove n is equal to k plus 1 is true. This is the tricky step. So you are having y to the power of k plus 1 minus 1. There should be a polynomial g of y such that this holds, right? Now let's focus on LHS. So y to the power of k plus 1 minus y. There's a trick that y to the power of k plus 1, then you were gonna add and subtract y to the power of k. So this will be y to the power of k, y to the power times y minus y to the power of k, y to the power of k minus 1. From here, can I take y to the power of k out, right? So this gives y to the power of k, y minus 1 plus y to the power of k minus 1. Now, let's focus on this chunk, y to the power of k. What is it from the star part? It's f of y, y minus 1. So this becomes y to the power of k, y minus 1 is f of y, y minus 1. You are getting this from star. Okay. Now, you have y minus 1 over here, y minus 1 over here. Can I pull it out? Right? So y minus 1 taken out will be y to the power of k plus f of y. This much is fine. Now what is required to prove? You need to get a polynomial g of y. You have y minus 1. Can I let the bracket part as g of y? Right? Am I allowed to do so? So y minus 1 is g of y, where your g of y is y to the power of k f of y. This is equal to your RHS. Okay. Now we can say, therefore, n is equal to k plus 1 is true. Mathematical induction. By mathematical induction, given statement is true for n is true for all natural number n. Okay,